Hello and good evening, CTS265, Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCNP route course, and this evening's video tutorial is going to be on Cisco Learning Labs Discovery Activity number 24. We're going to be taking a look at BGP for IPv6, and specifically what we're going to be doing is we're going to be doing V6 over V4 for the link between router 1 and router 2, and I believe we're doing V6 over V6 for the link between router 2 and router 3. So let's go ahead and dive in here. And if we take a look on router 1, if we say show run and section BGP, we can see that this is the current BGP configuration that we have here. And the big red flag, or I shouldn't say the red flag, but the indicator that we're going to be doing V4 or V6 over V4 is right here in the address family for IPv6. When we look at this, we can see we have two neighbor statements, but what kind of addresses are we using for the neighbors? Exactly, we're using IPv4 addresses. In fact, we even have a next hop route map set here on router 1. And so this tells us that our carrier is going to be excuse me, IPv4, and think of the carrier as a bus or a truck, right? It's going to be the vehicle that we use to communicate the IPv6 information out of this address family, specifically that network right there. And then think of the protocol that we're going to be communicating as the passenger, right? So the passengers get into the bus, or the passengers ride in a truck, and the truck and the bus moves them around the streets, just like the carrier, which is our protocol here, IPv4, is going to be used to transport IPv6. And that's one of the best analogies that I've heard. Very easy way to remember things. But again, when we see this IPv4 address here, we know immediately that if it's in the IPv6 address family and the peering is an IPv4 peering, we're using IPv4 as the carrier to transport the IPv6 protocol information. And the protocol, that is our passenger. So let's go ahead and clear our screen here. And on router 1, if I were to say show Bgp Ipv6 Unicast, let's pull this back just a skosh. You can see there that we have our IPv6 network that we're originating, which is at 2001:DB8:0:11:/64, with the next hop as the unspecified address. If we were to say show BGP IPv4 Unicast summary. I'm having all kinds of typing issues here. IPv4 Unicast summary. You can see we've got the information here. We've been up for 3 minutes. We've received 8 messages, sent 7, and it shows that the neighbor is that 172.16.12.2, which is going to be router 2. And if we looked at the IPv6 summary, we'd see the same thing, because again, remember, our peering is over the IPv4 address space. Now, remember that when we're dealing with the multi-protocol BGP with IPv4 and IPv6, that there are some legacy commands that will work, but there's also some new commands. So when I say show BGP IPv4 Unicast IPv4 Unicast, this is the same as saying show IP BGP, right? Except now when we're dealing with address families, we want to say show BGP and then the what's referred to as the AFI, or the address family identifier, so IPv6 if I'm interested in the IPv6 information, and then the SAFI, which is the subsequent address family identifier. So if I wanted to see multicast information, I would say show IPv6 multicast. But we're interested in the unicast, and there it is right there. And again, you can tell this was locally originated because we have a weight of 32,768. It is also the valid and the best route, and we know it was the network statement because we have in the origin code section, we have the I. So we know that this has been originated with the network statement. All right, so now let's go ahead. Let's take a look on router 2 here. So on router 2, if I say show run, pipe it to section BGP, you can see that we've got the network statement, and this is sort of a legacy configuration, and instead of legacy, I guess a better way to say it, this is a non-multi-protocol configuration right now. And we're going to come back to this because we're going to have to change this at some point, I believe, when we do some IPv6 work. If I were to say show Ip Bgp, right, I see that. If I say show Bgp Ipv6 Unicast, what do we get? Well, we get the same output. Even though we're not doing multi-protocol BGP yet, we can still run that command, and we're going to see the IPv4 information. All right, so finally, we'll step over to router 3, who is down here, and we're eventually, it looks like, going to have an IPv6 peering, I believe. So let's say show run section BGP. Again, sort of the non-multi-protocol BGP configuration, because there's no address families here, and we have sort of the old school config with the neighbor statements. There's no activate statements, which we'll talk about here shortly. So on router 3, let's see, do we have reachability out to router 1's 192.168.11.1? Let's source this from our loopback 1, and we do. So router 3 has reachability out to the loopback address on router 1. And so yes, so here we go. So step 4 in this lab, we're going to go ahead on router 2, and we're going to kick in the multi-protocol setup in BGP. So I'm going to go from privilege exec to global config, say router BGP 65,000. And now when I type in address family IPv6 Unicast, as soon as I type that in, I have now enabled multi-protocol BGP. And here's how you can tell. Let's take a look and see what the BGP config looks like now. Very, very different. So we went from a single section that was literally, I'll stay with the yellow here, we went from a single section that was literally these commands, these commands right here. And as soon as I typed in address family IPv6 Unicast enabling the IPv6 address family, we don't have any IPv6 information yet. We will here shortly, and we'll take a look at the config again. But take a look at this new section that we now have. This is where the network statement gets auto-magically moved for us, and you can see now we are activating the neighbors. And this is getting done automatically for us. And we're going to turn this off here in a second. So that's happening automatically. And you can see the next top self comes down here as well, because these are address family IPv4 specific settings. These are the more global settings that we have up top. So let's clear the config, and let's talk about the activate statement. So by default, when I put in a neighbor statement, and let's go ahead and put it in. So this is going to be a neighbor statement here under, oops, sorry, and actually NEIGH, if I can spell neighbor there. So 172.16.12.1. It looks like we're going to move, we're going to have IPv6 over IPv4. It looks like it could be all the way through here. We'll see what happens. So I have to put the activate statement in. Again, we already have the neighbor statement here, but I'm going to activate the peering. And there we go. You see the peering comes up. But again, this is an IPv4 neighbor statement under the IPv6 address family. So this is IPv6 is being communicated or transported in or inside the IPv4 bus, right? So we're sticking the IPv6 information into the IPv4 bus, and that bus is going to communicate the information. It's going to drive it around the network. So the next thing we're going to do is let's go ahead and add in our 2001 DB8:0:22:/64. So now we have a network statement in here as well. So let's say do show run section BGP. And as you can see, a very, very different looking BGP section in comparison to what we had earlier. So we had just this section, but now as soon as we set address family IPv6, we've got the two address family sections. You'll notice we have to activate each of the neighbors, right, with that activate statement if we don't have it set up to do this auto-magically for us. And then here is our IPv6 route that we're going to, that's our passenger who's going to ride in the IPv4 truck around the network. All right, so we're going to go ahead and move on to step number 5. So let's go over to router 1. We take a look on router 1 here, show Bgp Ipv6 Unicast summary, and you can see that we've received one prefix. So if I wanted to see the prefix that we received, I would simply say show Bgp Ipv6 Unicast, and there is the prefix we've received. And you can see that down toward the bottom here. I'm trying to get the desk scribble going again. Down here on the bottom, let's go ahead and extend this out. We'll drop that down there. So if you notice, the next hop address is very peculiar. So router 1 says the next hop to get to the 2001 DB8022::64, which we just originated off of router 2, is to go to this IPv6 address. And what it is that's an IPv4 address embedded in an IPv6 address. But here's the problem. You'll notice there's no greater than sign, which tells me that the BGP routing table does not recognize this route as best, because that next hop right there is 100% unreachable. And so what we would need to do is we would have to set the next hop attribute in a route map. And this is very similar to what we saw in the text. In fact, if we were to say show run section route map, you can see that we already have a route map here. And this is the route map we're using on router 1 to set the IPv6 next hop. And if I were to say show run section BGP, you can see that that route map is applied in the outbound direction to rewrite the next hop address for the network information that we are originating. So when this route right here, let me flip back over to the desk scribble. So this route right here, it's originated with the network statement. It's communicated to, we'll say over to router 2. And we set the next hop to router 1's address. So when this goes over to router 2 receives this IPv6 route in. It receives it over the IPv4 carrier, right? IPv4 is my truck, my bus, my carrier. Receives it, but it doesn't understand this crazy IPv4 embedded address inside this IPv6 address. This doesn't exist. So we basically rewrite it as it's going out to router 2. So we need to reciprocate on router 2. We're passing along information to router 2. Let me clear the screen here. So if I were to say do show IPv6, I'm sorry, do show BGP IPv6 Unicast, we can see that the route that's being originated right here, right? We see that this route that's being originated from, and it's kind of way off skew here, but it's by the network statement. This is the one we're originating from router 1. Here is the legitimate next hop. So that's the rewrite that's taking place because of the route map on router 1, so that when router 2 receives this route from router 1, router 2 knows, hey, my next hop to get to that route right there is this global unicast address, and that is the interface if I quickly scoot over here, that is the interface right here on router 1. So router 2 sees the next hop as that interface, and that's exactly what we want. So what are we going to do next? Well, we're going to dive in here to router 2, and we're going to do the exact same thing that you saw right here in the route map on router 1. And again, it's very straightforward. So let's go. Oops, sorry about that. Let's go ahead and step in, and we only have to do this once, right? Because we're going to set the next hop for all of the routes. So let me exit out, and we're going to say, whoops, router. We're going to say route map, and I'll just do the same thing. I'll use all caps though, just to differentiate it a little bit. Route map next hop permit 10, and what do we want to do? I want to set, and what do I want to set? I want to set the Ipv6 next hop. And what do we want to set it to? So when I'm router 2 now, when I'm advertising IPv6 prefixes over IPv4, what next hop address do I want my peers to see for my IPv6 prefixes? Well, I want it to be, since it's going to be router 1 specifically, we're going to set it to 2001 db8 : and I'm going to have to take a quick look back here. And I don't think we have, and actually I'm going to have to do a Control U and say do show IPv6, and I think it's .2 interface brief. And yes, it's 12.2, so we'll use that one there. So again, we're in the route map. We're going to set IPv6 next hop, and it's going to get set to 2001 db8 : 0 : 12 : 2. Got to be careful there. All right. So that is the next hop address, and so now that we have this route map, do show run section route map. Let's apply this to the neighbor statement in the IPv6 address family for router 1. So let's go ahead and say router BGP, I think it's 65, is it 100? Running 65,000, all right. 65.123. And address family IPv6. Again, I can put Unicast, but Unicast is the default. So all I need to say is address family IPv6. And let's take one. I always like to take a quick look to see. Do show run, pipe it to section, BGP. So that's what we've got now. So in the neighbor statement, I'm going to say neighbor 172.16.12.1, because we only want this route map to apply to the neighbor that we're peering with. I'm going to say route map. We called ours next hop. And now, in which direction do I want to have this next hop address rewritten? Exactly. We want to go ahead and use the outbound direction, because it's going to be when this prefix information is communicated to my eBGP peers in the outbound direction. So now that we've done that, let's go ahead and say do clear Ip Bgp, and I guess we'll go ahead. We'll go with a star here. We may be able to get away with the out, but I'm going to do the hard reset. And we've applied the route map. So let's see where we're at here. So now what we want to do is over on router 1, let's check and make sure show Bgp Ipv4 Unicast, and oops, sorry, neighbors. So, and actually we don't want neighbors. Unicast all. I always use all. Let me get this back here. Ipv6 Unicast. I always like to use all. All right, so there's the one route. We're waiting for the route that we previously had to come in. Let's see, show Ip Bgp, or actually show Ip Bgp neighbors. Do we have any neighbors? Neighbor summary, or actually just summary, sorry about that. And there we go. So we can see that we've received 2 prefixes. However, I'm waiting for this IPv6, and there we go. All right, good deal. So again, a quick reminder as to why BGP should not be your choice as an interior gateway routing protocol. Convergence is not its strong suit. All right, so down here below, you can see that we have the route, and this was originated with the network statement. We have the autonomous system from which we learned it, which was 65,000. And we know it's router 2 because we set it up. And now take a look at the next hop IP address. In fact, the next hop IP address has ensured that this can now be recursed by BGP, and that is definitely the best route. So from router 1, let's give it a try. Let's say ping 2001:db8:0:22:1, and we're going to source it from loopback 1, and we have success. So we're able to ping that network because, again, we have reachability to that next hop address. All right, so now we're going to go to step 9 in the lab if you're following along. So step 9 is to configure an internal BGP session between R2 and R3 using the loopback 0 IPv6 addresses. So here it looks like we are definitely going to be setting up a dual stack environment here where we have an IPv6 control plane that's going to be handling the some of the IPv6 traffic. So let's jump over here to router 2 and let's say do show run section BGP. So that's what we have right now. And again, router 2, the V4 or the V6 over V4 peering is with router 1. So we're already in here, so let's jump in and let's go ahead and put in our neighbor statement. It goes in the global configuration section here for BGP because this is not specific to the address family. So the neighbor is going to be 2001:0:3:3, and the remote AS, which indicates and dictates whether this is an iBGP peering or an eBGP peering, is 65,000. And then we have the neighbor 2001:db8:0:3:3. We're going to do the update source is going to be the loopback 0 address. Now remember that the update source needs to match the neighbor statement IP that's being used on the other side. All right, so we'll pause right here. So that goes in the global config section. So do show run section BGP, and you can see we have this new neighbor statement area right here for the iBGP peering, and it's in the sort of, we can consider this the global BGP configuration section. Now with IPv6, you'll notice, did it activate that immediately and automatically for us? No, it did not. So this is what I meant when we talked about those activate statements, is that when you put in the neighbor statement in the global area, I still need to come down to address family IPv6, and then again say neighbor 2001:db8:0:3:3 activate. And since this is an iBGP peering, and if we take a look here, you can see that router 3 has no other way out. So we want to make sure that any eBGP learn routing information that router 2 learns about, when he communicates that and advertises it to router 3, that information has the next hop changed to point to router 2. Because again, by default, eBGP routing information that's learned and then shared with an iBGP peer, the next hop is not changed. It'll stay the same, and so router 3 would see the next hop as being, in fact, let me come over here and see, and actually we need to configure, we need to configure the peering here on router 3, so it's not going to see anything now. But it would see the next hop as the router 1 address, and then if it didn't have information on how to get there, it would not have reachability. So we want to put that next hop self in there. All right, so let's save our config here just in case, and let's say show run section BGP and see what we see now. So you can see that we've got an IPv6 over IPv6 pairing that we're working on here for iBGP. We have our IPv6 over IPv4 peering here. This is the V6 over V6 at the top, right? So now let's jump onto router 3 and complete the V6 peering here. So we'll come over to router 3, privilege exec to global config, router BGP 65,000. And we're going to go to, actually, wait, we got to get the neighbor statements in the global area. So we're going to say 2001:db8:0:2:2. And the remote AS is us, so it's 65,000. It's iBGP peering. And then I'm just going to pull this back, and we want to make sure the update source, we're peering to the loopback 0 addresses. And then let's activate this. So, I'm sorry, not address family. Or actually, yes, I'm sorry, address family. Address family IPv6. And now we're going to go ahead and call that neighbor statement back, and we're simply going to say activate. And then let's make sure we change that next hop. And there you go. Look at that. Peering came up. And before I change, and actually, yeah, we would put next hop self in here. However, there is no, router 3 doesn't have any eBGP peerings. So if I were to leave this off, it's not going to hurt anything right now. However, it also doesn't hurt to go ahead and put it in there just in case. And let's originate our 2001:db8:0:33:/64 network. All right, so let's do a write mem. And now let's take a look and see when I say show run section BGP. Let's see how this configuration looks here. And again, not much new from router 2, right? But we can clearly see that we do not have a V4. I'm sorry, I keep saying it backwards. We do not have a V6 over V4 peering. So what we're doing right here is dual stack. We have two mutually exclusive control planes. We have an IPv6 control plane, and we have an IPv4 control plane. So here's the IPv4 control plane, right? And I should say up here we've got the global section. And here's the IPv6 control plane information. So this is a pure dual stack setup. We are not doing V6 over V4. So let's go ahead and verify here real quickly. And let's say show BGP Ipv6 Unicast summary. And there's our summary. We've received two prefixes. What if I were to say show BGP Ipv6 Unicast and neighbors? Whoops, let's pull this back. So we should see that we have just that single neighbor here. And again, a lot of output, but again, that's that single neighbor that we've got. And let's say show Ipv6 or show BGP Ipv6 Unicast. And so here is our information, right? So again, we've got the, and I'm sorry, if I said unspecified before, we've got the sort of the colon, which is indicating locally originated. And then we've got the best and valid, and it was learned via iBGP. Same thing here, best and valid. And the next hop addresses, because we're using the next hop self on router 2, these clearly show the next hop as being router 2, because as long as we can recurse to router 2 as router 3, we can get the information where it needs to go. So the test here that we're going to run, the final test is let's test reachability. So we'll say ping 2001:db8 :0:11:1 source loopback 1. And let's see if we've got reachability. And did I get that IP address right? Oh, I did not get the IP. I was like, this should be working, and it would if we had the correct address in there. And that is basically how you do your verification, is you test your reachability to make sure that those next hops are what you anticipate them to be. All right, well, this was, again, another fantastic activity out of that Cisco Learning Labs curriculum that we're working on in tandem with the Netacad labs. And this was Discovery Activity 24. And we saw both the best of both worlds, right? We saw how to configure IPv6 over IPv4 with BGP using a single IPv4 control plane, right? And then just telling that v4 control plane, hey, send your information, your v6 information, and use our IPv4 truck, right, or the bus, the carrier. Throw that IPv6 passenger information in there, your routing information, your IPv6 prefixes, and IPv4 will transport that to the neighbors for you. Now remember, the key there is we had to set the next hop. And remember, when you're setting that next hop value, it can be a little confusing. If I say show run section route map, it can be a little confusing. But remember, you're setting the next hop to the next hop of address of the router who is originating the routing information, because it's set in the outbound direction so that when I communicate or I transport that IPv6 information over IPv4, that the other side receiving that information doesn't embed the IPv4 address into an IPv6 address, because that's unreachable. And that's always going to be unreachable. So we want to set the next hop to our IPv6 address, have the route map in tandem with that neighbor statement rewrite the next hop so that when router 1 receives it, he doesn't see the IPv4 address, he sees the IPv6 address for router 2, and then he gets the information to him. And then we saw dual stack configuration on router 3, where we did IPv4 over v4, and then we did v6 over v6. All right, well, that wraps up Discovery 24. I will see you guys tomorrow night.